So for number 65, we're just finding a derivative, and we see we have y is expressed as the quotient of two functions. The derivative of, using the quotient rule, would be low d high, high d low. So low would be the denominator. So low is 1 minus cosecant of x d high. Now the d high means the derivative of the numerator, and the derivative of 1 is 0. The derivative of cosecant is negative cosecant of x cotangent of x. And that's just the first part. That's low d high, and minus high d low. So high is the 1 plus cosecant of x times d low. So the derivative of the denominator is, the derivative of 1 is 0, and the derivative of negative cosecant would be positive. So the derivative of positive cosecant is negative, and the derivative of negative is positive. So we have cosecant of x cotangent of x, and then all of that over low squared. So 1 minus cosecant of x squared. Now you will not want to leave it like that, but let's see what else we could do with that. We can factor out a cosecant cotangent. In fact, let's factor out a negative cosecant cotangent. So if we do that, we get negative cosecant cotangent, and then what are we left with here? We're left with 1 minus cosecant of x, and then we already factored out. So if we do this to make it easier to see, if I'm factoring out a negative cosecant cotangent, then I can change that minus sign there to a plus sign, and I can distribute that minus sign to that. So really what we have is plus 1 plus cosecant, plus 1 plus cosecant of x. And again, that's all over 1 minus cosecant of x squared. And then we can see in here the negative cosecant and the positive cosecant, those cancel each other out. All we have in the numerator then is 1 plus 1 times this. So we have a negative 2 cosecant of x cotangent of x all over 1 minus cosecant of x squared. And I'm looking at that thinking, yeah, that's how I would leave it, just like that. Oh, so that we have to find the derivative, and it says evaluate the derivative at the given point. So I almost stopped there, but this given point up there, that's why I write the given point, so it reminds me that there's more to do. So I have to evaluate y prime at the point pi over 6 negative 3, but I really only need the x value because y prime only depends on x. So we replace x with pi over 6. So the cosecant of pi over 6, cotangent of pi over 6, now I've got to go back to the unit circle, cosecant of pi over 6 again, and then squared. So if we remember, now we have to remember our unit circle. So the cosecant of pi over 6, if the sine of pi over 6 is 1/2, that means the cosecant of pi over 6, this is a convenient one, is equal to 2. And if the tangent of pi over 6 is radical 3 over 3, then the cotangent of pi over 6 is just radical 3. So that is nice because I don't have to worry about getting any fractions in here. So the cosecant of pi over 6, this guy right here, that has a value of 2. So we're going to multiply that by 2. And then the cotangent, we said that's radical 3. And then in the denominator we have cosecant of pi over 6, that's 2, and then squared. So that's negative 1 squared. So it really turns out to be a very convenient answer because all of this stuff right here, negative 1 squared is 1. And then we have negative 2 times 2 is 4. So we had negative 4 times radical 3. So that's y prime at that value, or at that point. And let's see, it says to use your graphing utility. Well, pausing, let me go ahead and get my graphing calculator and show you that. Okay, so just to show you how to type that in, if I type in 1 plus cosecant, I'm going to type it in as 1 plus 1 over sine, and then in the denominator it's 1, hard to get to that denominator, well, trust me, it says 1 minus 1 over sine of x. And when I graph that on the interval from 0 to 2, because I only need to see the graph at this point, pi over 6, negative 3. So I have surrounded that point. And so if I just second calculate the value of the function, I can do that, and I can type in pi divided by 3 equals, and so we see that's not good. It's supposed to be, oh, what did I just do? Second calculate value of pi divided by 6. I think I typed in a 3, yeah. So it was supposed to be y equals negative 3. So that's where the point is right there. And the question is, well, what's the derivative there? Well, I can second calculate now dy dx when x is equal to, at the value pi over 6. And so we see that dy dx is negative 6.92. So you can see that right there. And I bet if we typed in, let me just write it on the paper here, that's negative 6.928 and some change. And so if I type that into my calculator, I get negative 4 times the square root of 3. Oops, that's not what I want to do. I want to do it here. I want to do negative 4 times the square root of 3, and we get negative 6.928. So we can see on the graph that the derivative at pi over 6 has a value of negative 6.928, and it's at the coordinates pi over 6 comma negative 3. That's just what it wanted you to do, just to verify you got the right answer, typing in that value, and you can see the derivative at that point. And that's it.